Welcome friends, this is chapter number 3 of the 11th science, illustration number 12. The illustration number 12 is based on the stopping a distance. So let us see, we draw the one figure here, as shown in figure. Here there is a one car which have the initial velocity is a v0. And when the car applied the brake on the car, then we know that here the final velocity is 0 by applied the brake. This logic we'll try to understand by practical things. Let us see. Suppose there is a one Maruti car. This Maruti car is initial v0 velocity and start the motion. When reach to the final stage, applied the brake. When you applied the brake, the car is just moved back side. When the car is moving brake side, then the acceleration is in negative value. This is the basically concept of the stopping a distance. Slightly move back when you applied the brake on the car. So we can say from this model, the initial position is a v0 of the car. Final position, when brake is applied, the final velocity is 0. And then slightly motion backside. This slightly motion backside, that is the stopping a distance. Let us see. We'll try to understand by the figure. In this figure, we have just clear here that when brake is applied, the final velocity of the car, that is the getting the 0 final velocity, but the acceleration is the anti-acceleration is generated. So we know that the third equations of the motions here is a v square minus a v0 square is equal to twice ax. You know very well x we have to replace by the stopping a distance. So the final velocity, what is the final velocity? Is 0. So you can just cancel here. You are getting here v0 square is equal to is a 2 but is a anti-accelerations. So we are getting in the form of x transform in the form of ds, that is stopping a distance. Now remove the negative sign both the side. We are getting v0 square is equal to twice a into ds. But we have to give the capital of the stopping a distance ds. Then we can say ds is equal to v0 square upon 2a. Remember friends, the short form of this formula to remember ds proportional to v0 square. Remember that the stopping distance is directly proportional to the initial square of that velocity. Suppose the initial velocity is 2. Initial velocity is 2. Then stopping a distance is, we are getting the 4. So is a 4 times of the stopping a distance. You remember friends, when any big school and big hospital, there is a bump is there. At the time of the bump, we have to apply the brake. And that is in the form of limit of speed. Nothing but stopping a distance or braking a distance is there. So friends, this is the analytical example. You have to remember that ds is equal to v0 square upon 2a. Okay, thank you.